Hey guys, Mrs. Traver here. We're going to work through very quick notes on relating quantities on a graph, and I'm just going to walk through three quick examples with you. The first one is thinking about the situation of the volume of air in a balloon as it slowly blows up and then suddenly pops. So if you can kind of imagine somebody's holding a balloon and they're taking a deep breath and they're blowing into it, a little bit of air goes in, they take a breath, they blow into it again, a little bit more air, they do it again, a little bit more air, and they keep doing this until suddenly, as they're trying to blow it up, it pops, and then no air is left in the balloon. So we're looking at two different things here. This section is called relating quantities. I have two quantities in each of these situations. The first one here is volume. So what I mean by volume, by the way, is how much air is in the balloon. And then also the second quantity is kind of hiding. It's the time that goes by. So if there's a hidden quantity, it's the time that's going by. So time is going to be on our x-axis, and then the volume of the balloon will be on the y. And it goes to, it's nice to mention too that keep in mind that this graph, in real life, the coordinate plane has four quadrants, but in this specific situation, it doesn't make sense to talk about any other quadrants but quadrant one, simply because quadrant one includes positive time, and negative time doesn't really make sense. Similarly, volume of the balloon is never going to be negative. So talking about that doesn't really make sense. So we've bottlenecked ourselves into just the first quadrant in order to think about the situation. And we can do so by thinking about what's happening at each step along the way. So at the beginning of the scenario, time is 0 and there's no air in the balloon. So I can kind of think of there being a point there at the origin. And then you take a deep breath and you start blowing some air into the balloon. So time is going by and the volume of the balloon is going up. So some air got pumped into it. And then you pause for a second in blowing the balloon up and take a breath. In that breath, some time went by, but the volume of the balloon did not increase. So we can see that by the volume of the balloon staying the same and the time going by. Then again, let's blow some air into the balloon so it went up again. Let's take another breath. Time goes by, volume doesn't change. Let's begin to blow the balloon up. And then this third breath that we take, we try to blow the balloon up, and then suddenly it pops. So it goes from in one instant being at this level of volume to instantaneously having no volume. So it went right away to no volume. That's where it popped. So the whole deal about these relating story problems into graphs or relating quantities into a graph is a few different things. The first step is always to figure out what are your quantities. What are my quantities? You'll always have two. And then to make those into your axes. So those things are important. And by the way, with our axes, it is always going to be the situation where time is the x-axis and your y-axis is variable. So it'll change each time potentially. Sometimes it's going to be volume, sometimes it's going to be money, sometimes it'll be height, distance. This is some quantity. And time, by the way, could mean seconds or minutes or hours or days, maybe years, maybe just time in general, but some increment of time. From there, step 3 is really just to draw your graph. And I do that by walking through the story problem one step at a time. So thinking what's happening as time goes by each step along the way. Let's do another one. So we've got this phone bill that is $50 no matter what, and an extra $1 per minute for every minute over 200 that you use. So if you use no minutes at all, you're still going to pay $50. If you use 100 minutes, you'll pay $50. If you use 200 minutes, you'll pay $50. But anything over 200, you'll pay an extra $1 for. So let's first think, what are my quantities? Well, I've got dollars and I've got minutes. and minutes are an unit of time, so that'll go on the bottom of my axis. So minutes used, and then over here it is the cost of my bill. So let's see. On the last one, we didn't make any tick marks here to label our graph, but we do need a little bit. I do need to know that where 200 is here, and then maybe I'll split myself into 50, 100, 200, or 150, 200. So I'll split myself up there, and I need to know where $50 is. So let's set 50 to be here. That makes this be 100. That's the price of my bill. So let's see here. We said if we use no minutes at all, so 0 minutes used, my bill is $50. If I use 100 minutes, my bill is still $50. If I use 200 minutes, my bill is still $50. So you can see I've got a constant $50 bill for everything under 200 minutes. And then suddenly, after I start racking up some minutes at 250, I now all of a sudden have to pay $100. So it'll go up. And it'll keep going up from there. So I can kind of put a little arrow to indicate that. Let's do one more example, then we'll call it quits on these notes. My last one is a situation in school. Say I had the amount of students in my class before a bell, and I'm looking at tracking the amount of students. There's my first quantity. The amount of students that are in my room as time goes by before the bell. So I can just say time. I don't have to be much more specific than that. So let's say I have a class of 15 students. So let's say 5, 10, 15. And a while before the bell starts, there's nobody in my class, no students, so no students are in there. And then a group of 5 students comes in. So some time went by where all of a sudden, some time went by where nobody was in my room. And then suddenly 5 students came in all at once. And then students trickled in one at a time until the bell. So a student came in, a student came in, a student came in, a student came in, and so on, until all 15 students were in my room. And then time passed, but my students didn't increase. I still had the same 15 kids. So time went by, and the students stayed the same. So notice this jump here was 5 came in at once. That's what caused this vertical jump. And then this is students coming in consecutively over time. So a constant rate of change. All right. We're going to call it quits on these notes. I hope these examples have helped, and I will see you next time.